Uh, and today we're going to talk about aerobic cellular respiration and anaerobic cellular respiration. Aerobic cellular respiration has three parts to it. So the first part is glycolysis. Glycolysis wants to become a pyruvate. And to become a pyruvate, it has to go to glucose. And as soon as it becomes glucose, it has to go through different steps. So you look at the 6 carbons inside glucose. The 6 carbon first, they invest in ATP to be able to get 1 phosphate, and it becomes glucose 6 phosphate. Then it invests another ATP to have 2 phosphates on both sides, and it becomes 1,6 frutose 1,6 biphosphate. And after that, the molecule splits into 2 parts. So there's 1P on each side with 3Cs. So after that, it becomes G3P, which is glyctide 3 phosphate. And from there, it then gains phosphate that's floating around on each side, and also gains NADH, which makes it 1,3-diphosphoglutarate. And from there, it then gains an ATP by losing a phosphate, which makes it 3-phosphoglutarate. And after that, the phosphate attaches to the central carbon, which makes it 2-phosphoglutarate. And after that, it gains an ATP, 2 ATPs, and then you can only see the carbons, and it's pyruvate. After that, it changing stages by going from pyruvate goes to the mitochondria, but first has to go through a linking reaction. And the linking reaction removes carbon dioxide and then an NADH, which is electrons, changes the pyruvate and becomes acetyl C2. And acetyl C2 needs a helper, so it gets CoA, and it also wants to grow, so it wants to add up with oxaloacetate C4, and from there it doesn't need the helper anymore because it's getting bigger. So after C2 plus C4 add up, it becomes C6, which is citrate, and citrate then wants to become smaller, so then it removes a carbon by losing carbon dioxide and NADH, and becomes ketoglutarate, which is C5. From there, it wants to become smaller again, but this time it generates an ATP, loses carbons and NADH, and becomes succinate, which that is a C4. And then from that, it doesn't want to become smaller. It then changes form and becomes fumarate by losing an FADH2, which is also another electron carrier. And fumarate wants to become again an oxaloacetate. So from that, it then loses an NADH and becomes oxaloacetate. And from this process, it gains an ATP for each pyruvate. Like it gains an ATP because there's 2 pyruvate at the moment, which makes, because you get 1 ATP per thing, so there's another pyruvate there. And for glycolysis to pyruvate, you gain 4 and you lose 2, which makes 2 in total of ATPs. And the last one is electron transport chain. And in the electron transport chain, there's 4 complexes and 1 ATP synthase. In the first complex, it uses NADH electrons and electron carriers, and it deposits the high electrons, and then it goes through the hydrogen ions. In the second complex, FADH2 is taken and is going to be used in complex 3. In complex 3, FADH2 is used, and it uses the electrons to pump the hydrogens across. And in complex 4, it uses the remaining low electrons and hydrogens and oxygens to create water. And in the ATP synthase, the ions on the top go down into the spinning object into a spinning ATP synthase, which then, by the kinetic energy of the rotation that it has, the ATP and the hydrogen fuse together to become ATP. Yeah, and that was aerobic cellular respiration. And the electron transport chain gains 32 ATP per second, I think. So from all of that, you get 36 ATP, Well, in the anaerobic cellular respiration, while it gains by fermentation, yeast fermentation mostly only 2 ATP, and animals we create lactic acid which only gains 2 ATP. So there's 36 ATP on the side, aerobic, which means with oxygen, and anaerobic, which means without oxygen. So there's 36 with oxygen, 4 with non-oxygen. So you prefer with oxygen, and that's all from your Bioblaster. See you, Mr. Sal.